doing objective 23 today. We are going to graph tangent functions. So I asked you a minute ago, I gave you this chart, and I asked you to go to your unit circle, and I asked you to find the tangent at each of those points, okay? So we know the tangent of x, the tangent is equal to the sine over the cosine, or the y divided by the x. So if you go to 0 on your unit circle, what's the coordinate point? First of all, it's 0. The coordinate point is 1, 0. So if you divide the y, which is 0, divided by 1, what will it equal? 0. Okay, and that's how we're working this out. So at pi over 6, what's the tangent? Square root of 3 over 3. Now, I want you to actually go ahead and give me a decimal for that, because if I say plot, you know, over pi over 6 and up square root of 3 over 3, you're going to be like, well, where's square root of 3 over 3? So what is, so point, estimated it to be around 0.57? 58? Okay, 0.58. Thank you very much. Okay. How about pi over 4? What's the tangent? 1? Everybody agree with 1? Okay. How about pi over 3? What's the tangent? Square root of 3. And we would estimate that to be around what? 1.73. Okay. And how about at pi over 2? It is undefined. When you divide the y by the x, you end up with 1 divided by 0, and that is undefined. And if you're just joining us, we talked about that that's going to create an asymptote, meaning if at the point where it's undefined, okay, meaning when I draw it, it's going to approach that line and get really, really close to it, but never, ever, ever quite touch it. Okay, so what I'd like to do is, everybody got these points down? Because I need you to help me. We're going to actually graph this. This is the same thing, y equals the tangent of x. So let's take a minute and we're going to graph it. I'm going to scoot it over. All right, so we've got 0, 0 here. I'm going to do, what was my first point going across in radians? Pi over 6, and then pi over 4, and then pi over 3, and then pi over 2, okay? So, and we're going to go up 0, 1, 2, I'll go up to 3, okay? First of all, we know that there is a vertical asymptote where? Where is it undefined? At pi over 2. So I like to draw those first, okay? So I'm going to draw a dotted line right here at pi over 2, okay? Basically, the function will get very, very close to that point, but that is a point where it does not exist, so it doesn't ever quite touch that, okay? An asymptote is where the function, it's approaching it, but it doesn't ever touch it, okay? All right, so let's plot these points. So our first point is going to be 0, 0, right? Okay, 0, 0. At 0, the tangent's equal to 0. At pi over 6, what's the tangent? 0.5. So 0.5 would be somewhere around halfway between 0 and 1. Okay, maybe a little past halfway. Okay, at pi over 4, where is it? It's at 1. At pi over 3, where is it? At 1.3? 1.73, so it's going to be up here. Okay, so I know if I drew this, now first of all, that is not a straight line at all. If I drew this, it's going to come up looking like this, and then where's it going to head? Is it going to head towards this line? Yes, it is. but it's going to go like this, and it's going to get really, really close to it, but it doesn't ever quite touch it. So it's kind of got a curve, and then it changes direction and goes up like so. Okay? Now, I'd like to go back that many. For example, I'd like to go negative pi over 6, negative pi over 4, negative pi over 3, and then pi over 2. Okay? So we know on our unit circle, if you go to your handy dandy copy of our unit circle, if I'm going negative pi over 6, where am I actually going? Right. We're going to go down here to quadrant 4, so we'll actually be at 11 pi over 6. Does everybody understand that? Okay. So, can you take a minute, divide negative 1/2 by square root of 3 over 2, and tell me where I would be at negative pi over 6. It's not, well, it's not positive 0.58. It's now going to be, because you're dividing negative 1/2 by positive, and a negative divided by a positive is a negative. Okay, so it's still going to be the same thing. It's just going to be negative. So where is negative 0.58? Same, but down here. Okay. Okay. How about negative pi over 4? What's the tangent? Negative 1. Okay. How about negative pi over 3? Negative 1.73. Okay. How about negative pi over 2? How about down at that? Is it still going to be undefined? So what does that create? A vertical asymptote. Okay, so it's still going to have a vertical asymptote right here. So if we drew this one, it's going to come down like so. And then it's going to keep going towards that vertical asymptote. So this is what a basic tangent function looks like. Okay, now, please know, now that we know the basic shape looks like this. It's heading towards the vertical asymptote, then it comes through here, and then it goes up like so, right? That is the basic shape of a tangent function. So I use the unit circle to show you where it comes from. But now that we know the basic shape, we're going to now do some things to it. You follow me along? Shift it, vertically stretch it, things like that. I do want you to know, what was that one sentence on the other page that said? It said, the tangent and cotangents have a period of pi. So we know sine and cosines, to do one full wave in the basic is a period of 2 pi, correct? I can do one full tangent graph, and everybody says, but it looks like it's just going to pi over 2. But the way a tangent graph, let's look at the entire length. This is one full right here. You with me? What's the distance from here to here? Pi over 2. What's the distance from here to here? And if you put them together, how far is one full tangent? Nope. Pi over 2 and pi over 2? It's just pi. Does that make sense? One full. So from here to here is just pi. Do you understand that? Okay. So tangents, basically, they don't start at 0 and then go to pi unless they're being shifted. The basic one, 0's the middle. It goes back pi over 2 to negative pi over 2, and then goes forward pi over 2. Does that make sense? So it doesn't start at 0. Do you understand that? It doesn't go from 0 to pi. The basic goes from negative pi over 2 to pi over 2, which is still a length of pi, but it doesn't start at 0. Do you see the difference? I don't want you to think that the wave is going to always start at 0 like sine and cosines. Okay? All right. So let's look at what we have. This is example 2, but now we're going to look at y equals 2 tangent of x. Okay? If you're still getting used to this, you can take what you just found for each point and do what with it? Times it by 2 to get your new points. But let's just look at the basic. Okay? First of all, am I shifting this anywhere? No. Okay. So at pi over 2, we have our vertical asymptote. At negative pi over 2, we have our vertical asymptote. You with me so far? Yes? The basic one, we know, goes like this, then it goes to 0.5, then it goes to 1, then it goes to this, and it heads up like so. And then same thing down here, negative 0.5, 1, 1.7, and so it's going to go down like this and head towards those asymptotes. Okay, that's your basic. If I want to graph it, if I times something by 2, I wish I had my rubber band. Somebody got a hair rubber band on their wrist? Oh, look. No. Oh, I got one. Okay. If I want to times something by 2, we know when you add or you subtract, it shifts it up or it shifts it down. You know, if I stick something in the parentheses, x minus this or x plus this, it's going to shift it to the right or shift it to the left. Does everybody understand so far? What happens when you times it by 2, a function? It stretches it. So check it out. Here's your function. If I times it by something greater than 1, it's going to pull it vertically. Okay? It's going to make it skinny. Do you understand? So if I times it by something less than 1, give me something that's less than 1. Yeah, 0.4 or like a fraction. Like if there was 1/4 or 1/3 or anything less than 1, like a fraction. It would take it and compress it vertically, means squash it. So what would happen to it? It'd make it wider, right? So we know that this is timesing by 2. So what if I could pull this string and I could stretch it vertically? What's it going to do to it? Straighter or almost like, yeah, straighter, almost, or like steeper. Straighter and steeper. Okay, does that make sense? Like, so that's what I want you to think about. Like, think about it like a string and stretch it. And so it's going to take it and make it not a complete straight line at all. It's still got a curve towards those asymptotes. Okay, so if you wanted to, you could times each one by 2. Okay, so like here, the first point's at 0. If I times 0 by 2, where's it at? It's still at 0. Okay. This one's 0.58. If you times it by 2, what would you get? What's 0.58 times 2? Right. Close to 1, but a little bit above. So it's going to go something like this. Okay. If you times 1 by 2, where's this point going? Up to 2. And if you times 1.73 times 2, you get 3. So it's going to go like this. So it's now going to go like this, but then it's still going to curve up towards that asymptote. So it's not completely straight. If it's completely straight, it would intersect it. Okay? And then same thing here. This one's going to go down to a little bit below 1. This will go down to 2. This one will go down to 3. And so it's going to look something like that, but then head towards that asymptote as well. Okay? Any questions on when you times by a number, it is going to vertically stretch it? Okay. So far, so good? Okay. So what do you think, based on what we know about sine and cosine graphs, what do you think this 2 is going to do to it? What's it going to affect? Is it going to shift it? Or, like, what if I made this the sine of 2x? What does the 2 affect? The period. Okay? Now, if it's a sine function, how do you get the period? 2 pi divided by 2, so the new period would be pi. But what do you think we're going to divide by? Why are we dividing by pi? The basic period is only pi. So now we're going to take this and divide pi by 2. So now we are going to do one full tangent function between, that's going to be the length of pi over 2. Okay, so our period is going to be pi over 2. Period is going to be pi over 2. So let's think about this. Okay, let's think about this. Am I going to go all the way out here? If I don't want to go from 0 to pi over 2 and that be the length of it. I want 0 to be the middle. So I want to go an equal distance back this way and an equal distance back this way. And it be pi, the whole thing be pi over 2. So where would I go to here? Pi over 4. Where would I go to here? Does everybody agree the distance between negative pi over 4 and positive pi over 4 is a full distance of pi over 2? Okay, so now we're not shifting it anywhere else. Am I stretching it further? No. So I still know, like, you can sketch this. It's still going to look the same, except now like that. It is. So if I graph like the original goes all the way out here to pi over 2, right? And the original goes all the way out to here to pi over 2. So if I graph the original, it would look, pi over 4 is at 1. The original is going to look like this and head towards that line. Okay? Does everybody understand? So, did I lose you on that? Yes, I did. Kind of. Where, can you ask me a good question that I could help? Does everybody understand why I went to pi over 4 and negative pi over 4? So, do you understand that the period's going to be pi over 2? Do you know where we got that? We took, because a basic period is pi. So we're going to take pi and divide it by 2, just like you did with sine and cosine. Okay, but with sine and cosine, you divided 2 pi over whatever the k was. Now we're going to divide pi by whatever the k was. But you're not going to go from 0 to pi over 2. Does that make sense? You're not going to do that. I want the distance, I want 0, I want my origin to split it. So what could you do to pi over 2 to figure out the distance from here and distance from here? You could take pi over 2 and divide it by 2, and that would tell you to take this out to pi over 4 and take this out to negative pi over 4. Yes, yes. Okay. You want the origin or the axis, the y-axis, to split your period in half. Does that make sense? All right. So let me do this. Let me give you a chance to think about this. Try to graph this. Look at your period. What do we know is going to happen this time? It's going to shift. Shift to the right or shift to the left? To the right. Pi over 4. Okay? So let's see if you can figure it out. I'll give you a second. All right. So first of all, what does this 2 mean? This is your period, okay? And we find our period in sine and cosine, you divide 2 pi by k, but with tangent, you're going to divide pi by the 2. So our period is now going to be pi over 2. But again, when we start to set this up, when we start to set this up, you want the y-axis to split your period in half. You understand what I'm saying about that? So basically, to figure out how far you go out this way and how far you go out this way, you want this distance in either direction to be pi over 2, your period. So really what you need to do to figure out where you go to here is you need to take this and divide it by 2. Okay? And you can do that in your calculator. You can do 1/2 divided by 2. Okay, what are you going to get? You're going to get pi over 4 and negative pi over 4. Okay? So if I drew this just based on the period, it's going to go like this. Okay? And your asymptotes would be right here at negative pi over 4 and positive pi over 4. You with me so far? But this makes a phase shift, positive pi over 4. So really, I normally start at 0 for my center, but if I shift it to the right, pi over 4, where would that first point be? Or the center point? It's going to be at pi over 4. It normally is at 0, but then I'm going to shift it to the right. So it's going to be at pi over 4. And so instead of the old one would look like this, like so, okay? But if I shift it to the right, it's now going to go, if I take pi over 4 to the right, pi over 4, this is going to be pi over 2. So it's still going to, this is going to be your asymptote at this point in time, because you're going to head up like so, and then you're going to head down like this towards the y-axis. And I would not make the y-axis an asymptote. I mean, yes, it's heading towards the y-axis because the shape stays the same. Do you understand? Like you're just shifting it. But on the y-axis, it's not undefined because it's 0. Does that make sense? Okay. Now, if it were at pi over 4, negative pi over 4, these would be your asymptotes. Okay. But because this is at 0, it's still going to have the same shape. So it should look like this. Okay, it should go from 0 to pi over 2 because I shifted it. Okay? I wouldn't. You don't. There it is. He's heading towards the y. Does that make sense? But this is not an undefined point. Huh? No, it's not. I mean, it's going to approach it. Does that make sense? Because the graph is, I'm not changing the shape of the graph. I'm not changing it so that it, does that make sense? Like it was approaching that undefined point over on this side, and it was approaching that undefined point on this side. All I did is I took it and went like this. So it's approaching that y-axis, but I'm not going to tell it to touch it because I'm not going to change the shape of it. It's still going to head down and get really close, but never quite touch it. But it's not a point of being undefined. Does that make sense? Okay. All right. So we're going to stop right there. I want you to attempt these. Okay. I just want you to attempt them. Okay? And I'd like to collect them when you leave. And I'm going to come around and I will answer questions. Okay? I'd like to correct. And if you don't hit them all, that's fine. You don't hit them all. I just want to look and see if you're getting the gist of it.